please find in your notes packet where we left off. The next section should say general properties of groups. General properties of groups. What we're talking about today are the different groups in the periodic table, and remember that groups go up and down. So groups, columns, and families, all three of those words mean the same thing. That's the up and down sections of the periodic table. So we're talking about the individual groups and what their properties are today. Last week we mentioned that the periodic table is organized pretty much in two ways. It goes by atomic number, and then within a group, so within a column, up and down, the elements in that group have similar properties or similar characteristics. They might look the same. They might behave the same. They might react with the same things or have similar physical properties as well. So what we're talking about today are those general properties of the individual groups. We're going to start with the left-hand side. Group 1 on the left-hand side of the periodic table is called the alkali metals. So if you can see all the way to the left, this includes things like lithium, sodium, and potassium. It's that first column on the left-hand side, the alkali metals. Things that these metals are known for. They are very soft. In fact, they can be cut with a knife. And that's something that you don't typically think of when you think of a metal. When we think of metals, we think of things like iron and copper. You can't really cut iron with a knife, especially not with a pocket knife or with a butter knife. These metals in this first column are so soft that you can in fact cut them with a butter knife. And in a few weeks, you'll get to see that. We'll do a little demonstration with these after Thanksgiving, and I'll show you that they can in fact be cut with a knife. These are also very reactive. These are the most reactive of all of the metals. One of the things that they react very violently with is water. You may have seen this on Mythbusters or YouTube. Sodium in particular has made the rounds in a viral video when you react it with water. We will do this in a few weeks on a pretty small scale, so you at least get to see it. But if you take a piece of sodium or a piece of lithium and you throw it into water, it will more or less explode. Sometimes it starts on fire. There's a lot of popping and hissing and spattering of metal and water. So it's kind of a neat reaction to watch, although it can be very dangerous. Oops. And last thing we need to know about this group is that they are not found in nature in their pure form. That means you're not going to be able to go outside and dig up a chunk of sodium from under the ground. When you find these elements in nature, they're always in a compound. They're bonded with something else. For example, sodium chloride, we know as table salt. Table salt is a natural mineral. You can go to the right locations and mine for salt. You can find it naturally. Pure sodium, on the other hand, you're not going to find naturally. You will not find just a chunk of it under the ground. Group 2, very similar name, called the alkaline earth metals. These are also fairly soft metals, although they're not quite as soft as the first group. The picture that you see here is of calcium in its pure state, and that's something that we don't necessarily think of as a metal either. You think of calcium when you think of vitamins in your bones. You don't necessarily think of the fact that it's actually a metal. And it does look somewhat metallic in its natural state, or in its pure state, I should say. The alkaline earth metals are reactive, although they are less reactive than the first column. These are also not found in nature in their pure form. So when you find them naturally, they're always bonded to something else. Next, we're going to skip kick over to the right-hand side of the periodic table. We'll come back to the middle towards the end, but we're going to skip to the right-hand side. When you skip to the right-hand side, then we're looking at groups 13 through 16. And these go by element family names. So in other words, each column is named after the element at the top of that column. So the boron family, the carbon family, the nitrogen family, and the oxygen family. They're named after the element at the top of the column. These groups have a wide variety of properties. There's lots of different kinds of elements in these groups. If you look at these groups, there's solids, there's there's solids and gases, there's metals, there's semi-metals, and there's nonmetals. So it might make sense then that these groups have a lot of different properties that go with them. And they have that wide variety of properties because there are so many different kinds of elements in these groups. Metals are the things in these groups with yellow cards on our periodic table on the wall. Semi-metals have green cards, non-metals have blue cards. Solids and gases. The solid letters are colored blue, the gases letters are colored green. Next group we have is group 17. Group 17 is called the halogens. The halogens are the most reactive of the nonmetals. This is the column that starts with fluorine, chlorine, bromine. It also includes iodine and astatine. These are the most reactive of the nonmetals. Here's a picture of bromine in its actual liquid state. It's kind of a rusty brown color. Here's a picture of chlorine. Chlorine is a greenish yellow gas. And iodine. Iodine is a really dark purple kind of solid crystal. These are the most reactive of the nonmetals. And in fact, they all kind of smell the same too. If you know the smell of chlorine, like the smell of a swimming pool, iodine and bromine and fluorine, they all kind of have that same chlorine-y kind of smell. They're slightly different from each other, but it's a very distinctive odor, and it goes with the halogen group. And of course, as you could tell from the color coding, we have a couple of solids in this group, we have a couple of gases, and one liquid. On the end, we have the noble gases, group 18. They are very unreactive. They are also colorless and odorless. You can't see them, you can't smell them. Very unreactive means that they don't make compounds very easily. They don't bond with other things very easily. Another name for these is called the inert gases. Inert means that they don't react. And of course, we have to have a fun element cartoon since we just did that for our homework. What are they filling the frogs with? Helium, because helium is lighter than air. And so, of course, all the balloons that you're used to are filled with helium. What does helium do to your voice? It raises it and makes it sound like Mickey Mouse. And that has to do with the density of the gas as it passes over your vocal cords. I'm sure none of you have ever done that, though, because it is somewhat dangerous. Okay, back to the middle. Groups 3 through 12 are called the transition metals. This is a pretty wide group. There are lots of elements in this section, and so there are lots of different properties in this section. They range from things that are very reactive to things that are relatively calm. One thing that they are known for is making brightly colored compounds. So if you are into art and pigments and things that they put in paint to make those specific colors, probably you're familiar with a lot of transition metals. This color that's used for ceramics is called cobalt blue because it's made from cobalt. Iron usually makes red compounds. You probably could guess that from the color of rust. Nickel usually makes kind of greenish colored compounds. Copper can be greenish or bluish colored compounds. Titanium is something that's used for white paint pretty frequently. So we have a lot of different elements in this section. Some are reactive, some are not. But one thing that they are all known for is their use as brightly colored compounds are used for pigments. Such as cobalt blue, titanium white, ooh, cadmium, I forgot that one. Cadmium is a very bright kind of canary yellow when it's used as a pigment.